Welcome. This is notes on apportionment section in the apportionment series, and we are on page 4. So, let's talk about Adams and Webster's methods for apportioning seats in the representative branch of government to 5 states. That'll be our example. So, we have 5 states. Here are their populations. So, you can go roundabout estimate and say to yourself, state B should not get more than twice as many seats as state E because they don't quite have twice as many people. We have 137 seats to distribute. We can't break those seats into fractional parts, so what's our technique going to be to get the most fair apportionment? So again, we have a screenshot from a spreadsheet that is doing all these calculations. We see seats available typed in at 137. The populations of the individual states should all match. And then the divisor here is the standard divisor. We've divided 27,400,000 by 137, but let's just ensure that we did that correctly. So standard divisor is total population divided by total number of seats. Let's see if we can get our calculator going. We have 27,400,000, and we want to divide that by the number of seats we have is indeed 200,000. So then what we do with that divisor, the standard divisor, is we divide it into each of the populations, and it gives us out this quota. And that was like the ideal amount of seats that state A would get. We say, oh, bummer, we can't shell out these fractional parts, so we're going to have to do some rounding somewhere. In the previous video, we talked about Jefferson's method, which used the lower boundary. So just rounding all of these numbers down, you see 31.9 rounds to 31. Just pull off the integer part and adjust the divisor until we've apportioned exactly as many seats as we started with, which is 137. In Adams's method, we'll look at the upper rounding, so 41.2 rounds to 42, 31.9 rounds to 32. Everybody rounds up, and we'll adjust the divisor until we've apportioned exactly 137 seats. You can see we haven't done that right now, but this will be what we'll look at to deal with Adams's method. And then there's conventional rounding. So 41.2 rounds to 41, whereas 31.9 rounds to 32. And this is the column we'll look at Webster's method. And we see that also in Webster's method, we haven't finished the apportionment because we also haven't apportioned exactly 137. And both methods will involve changing the divisor until those sums work out right. This is Jefferson. So actually all three. So let's write that over on the side. Write that in a color that we haven't really used yet. Okay. All three methods rely on changing the divisor until the total seats equals the seats available. So we can see that the standard divisor does not work for any of the three methods because none of the total seats allotted right now is 137. So let's work with Adams's method first. Right now we've given out 139 seats. We've given out too many seats because we overshot by 2. this is like people we need to reduce the number of seats. So that means that each representative working right now is going to have to represent more people. One way to think about this is if all the representatives represented 200,000 people exactly, then we would need 139. No, not exactly. If each representative was representing 200,000 people, then we would need 139 seats in order to satisfy these 5 states with their corresponding populations. But since we have only 137 seats, we need each representative to do more work. We need to increase the divisor in order to decrease the number of seats allotted. So let's see what happens when we do that. Let's increase the divisor to 2100. And if the divisor, not 2100, 201,000. So notice that we've increased the divisor to increase divisor in order to decrease apportionment, total apportionment. And you can see that in fact these numbers went down. 134 changed to 133, 139 changed to 138, and this 138 went to 136. And none of the methods is this a workable divisor, because none of these numbers add up to 137. We're still working with Adams's method, so we need to increase the divisor yet more in order to decrease this 138. And you are in a guess and check method, so just increasing this over and over again until these numbers add up just right is literally your process. So if you're like, well, we're getting pretty close, let's be safe and increase to 202,000, I would say that would be a good guess. Turns out, however, that you need to increase it quite a bit more. So let's scroll down and let's just reveal all of the tables. And we can remind ourselves of the key. This is Jefferson's method. We have Adams's method and Webster's, the jaw. So with 205,500 people as the divisor, that's how many people are represented by each of the 137 representatives. We succeed in Adams's method. So this is the allotment. This is the apportionment that works for Adams. Adams is right. And how do you know it works? Like, working just means that number in the total is 137, because that's how many seats were apportioned. And so that's it. State A gets 41, State B gets 32, and so on. And this manipulation of the divisor until this works is just to get these numbers. 205,500 is not the only number that works. There's a range of values, but that range of values will always that sums up to 137 right here will always produce the same set of numbers: 41, 32, 25, 22, and 17. Now for Webster's method, we from the standard quota, we did have to increase the divisor. We can scroll back up for that. Notice that with the standard divisor of 200,000, we had, via conventional rounding, apportioned 138 seats when we only had 137. So we still need to increase the divisor. But when we moved to 201,000, so this top table, we actually didn't apportion enough. So when we don't apportion enough seats, we have to bring the divisor back down. The representatives need to do less work. They need to represent fewer people, because we're going to have room for one more representative. And so decreasing the divisor to 200,500 means that the populations divided by that divisor produce quotas that, when rounded under a conventional rounding scheme, so 41.09 will go to 41, whereas 31.8 will go to 32, produces a list of numbers that sum together add to 137. And so that's how you know that that is an appropriate apportionment. And so the last thing to do, see, is that really going to show up? Yeah. Is to compare these two apportionments from Adams and Webster. Notice we didn't succeed in getting one for Jefferson, but that's okay. We're just talking about Adams and Webster. And notice that the apportionments are almost the same. They're almost the same, except for in the apportionments to D and E, which differ by just 1. So the methods are different, and you can't just, choosing them succeeds in apportioning the seats, but states D and E obviously have an interest in the exact method at which we do this apportionment, because the people of those states will be getting more say in the form of government based on whichever apportionment method is used. So that's Adams and Webster's. Just like Jefferson, you use a manipulation of a divisor and some kind of rounding scheme to produce your apportionment. So these are often called divisor methods of apportionment. And in the future, we'll look at the Huntington-Hill method, which uses yet another rounding scheme. And that will be in the video coming up. But it will still rely on changing the divisor to make the total allotment or apportionment of seats to be exactly as many as you have available. So that's it. See you in the next video.